The first question I want to answer is, why should I build a Hyper-V lab at all? Why not just buy a production server and install Hyper-V? Well, there's a number of great reasons to build a lab, and they vary from person to person and from company to company. Those reasons always include learning. With Windows Server 2012 Hyper-V being all new, just about every Windows admin out there wants to learn it, and you don't want to do it in production. You don't want to risk your job or use expensive production infrastructure servers just to learn Microsoft Hyper-V. The second reason is certification. New certifications covering Windows Server 2012 Hyper-V and Microsoft Private Cloud are now out and available, and you need to get started learning and preparing to achieve those certifications. Those certifications are going to be great ways to differentiate yourself from other Windows Server administrators out there so that you can prove your expert knowledge in virtualization and cloud computing. The third reason is testing. Whether it's creating a proof of concept for your company to show how Hyper-V can run your company's applications, or testing your management applications with Hyper-V, utilizing Microsoft Hyper-V for testing is a great use case for a Hyper-V lab. The fourth reason is development. Many companies want to develop applications around Hyper-V or even create development environments inside Hyper-V. This is because of how easy it is to snapshot virtual machines, clone virtual machines, and create entire new development environments in just seconds utilizing Microsoft Hyper-V. Now, personally, I run my own home lab environment that I use to learn about Hyper-V and other hypervisors. It helps me to test advanced features, to demonstrate the power of virtualization, and even to prepare for certifications related to virtualization and cloud computing. So how do you build a Hyper-V lab? Well, let's find out. There are two ways to build a Hyper-V lab, either physical or virtual. With the physical option, you are using very likely lower-end, less expensive physical servers than what you use in production. You install Windows 2012 and Hyper-V directly on those servers. Now, you may want to have some low-end shared storage around, like a small NAS or a small SAN, to try out some advanced features. You could use the free version of Hyper-V Server so that there's no software cost involved, or you could purchase the commercial edition of Windows Server 2012. Now, the upside to this physical lab option is that you have dedicated physical servers with decent performance. However, the downside is the cost and the expense associated with purchasing those physical servers, the space they're going to require, the potential noise, the ongoing electricity costs, and the need for periodic hardware refresh. The 4 servers that you see there in the graphic are actually 4 servers I had in my own home lab in the past. They perform quite well, although on the flip side, they put out a lot of heat in the room, and they also made a lot of noise in the room to the point that I even had to close the door so that I couldn't hear them down the hall. So a physical lab may be a great option if you have an extra room, maybe a basement, let's say, to put them in, or let's say that you work in an office environment, maybe there's a spare office that you could use to keep the physical Hyper-V lab for your learning and testing purposes. Now, the other option, the second option, is the virtual lab option. When building a virtual lab, you run Hyper-V nested inside a hypervisor. For example, you could run VMware Workstation on your laptop or desktop, and you could run Windows Server 2012 Hyper-V as a virtual machine, and even power on virtual machines inside Hyper-V. Those powered on virtual machines are called nested virtual machines because they run 2 hypervisors deep. Unfortunately, today there's no way to run Hyper-V inside of Hyper-V. You can only run Hyper-V inside of VMware vSphere or the free ESXi hypervisor or VMware Workstation. Of course, the upside to the virtual option is that there's no additional cost for hardware. Most likely, you can use your existing desktop or laptop system, assuming they have enough horsepower, enough CPU, RAM, and disk storage, and they also have to be relatively new because the CPU has to support either AMD V or Intel VT. Those are virtualization technology features built into the CPU. You can get the hypervisor you use on a free 30-day or more evaluation, and then you could use the free version of Hyper-V Server 2012 if you want to go completely free on the software side. Of course, if you wanted to spend a little bit of money, you could purchase, let's say, VMware Workstation and purchase the commercial version of Windows Server 2012 to run inside. Now, the downside, of course, to the virtual lab option is that your laptop or desktop system will be heavily used by this Hyper-V lab when you power it up. It will use all the RAM and storage performance that it can get, and even then, there's going to be limitations as to what you can do and how well it will perform. Still, the virtual lab is portable, it's small, and it's the easiest type of lab to get started with. Now, let me show you examples of both types of labs, physical and virtual. Here we are connected by remote desktop to one of the two physical Hyper-V servers I have in my physical Hyper-V virtualization lab. This host, which I called Hyper-V 1, is a real physical server which I purchased from eBay for about $750. I have two of these servers in my Hyper-V lab, and let's go down here to the Start menu. I'll right-click on my computer and go down to Properties. And you can see that this host has two processors. They're quad-core processors running at 2.5 gigahertz. It has 24 gigs of RAM installed. And this is actually a 1U rack server. It's very loud, but it's also very high performance. And I can run a lot of Hyper-V virtual machines on this. So this is a good option for a physical Hyper-V lab. However, I wouldn't put it in your office or in your bedroom because honestly, it's very loud. So keep these things in mind when you go to shop for home Hyper-V physical servers. You want to determine how much power they're going to consume and how much noise and heat they're going to put out. On the other hand, here I have VMware Workstation installed and running on my local laptop. Inside it, I have a Windows Server 2012 Hyper-V host running. And if we go inside here, I can actually maximize the screen. And then you can see I have Hyper-V Manager running. And inside I have a new virtual machine that I just created. Its state is running. So this is a nested virtual machine that I've powered on inside Hyper-V that's running inside Workstation, that's running inside Windows 7, which is installed on my local laptop system. So you could do the same thing to create your own virtual lab. By the way, this Windows 7 laptop is an i7, an Intel i7 processor. It's a quad-core CPU with Intel VT enabled. The host has 6 gigabytes of RAM, but this virtual machine has 4 gigabytes of RAM assigned and 2 virtual CPUs. Think about how inside here you could go in VMware Workstation and you could create multiple Windows Server 2012 virtual machines and even a shared, let's say, iSCSI virtual machine to create a shared storage area network. With that, you could test all kinds of Hyper-V advanced features, learn about Hyper-V, prepare for a certification, and do some application development. However, the host, whether it be a desktop or laptop server that you run it on, is going to need to have plenty of CPU, as much RAM as you can put in it, and even, let's say, a solid-state disk drive if you want to really get some heavy storage I/O performance out of it. So the more resources you have, the more you can do, and the better the virtual Hyper-V lab is going to perform. I strongly believe that building your own lab is the way to go. No matter what option you choose, physical or virtual, gaining hands-on experience is the most successful route to learning any new technology. Thanks for watching this lesson on building a Windows Server 2012 Hyper-V Lab.